Now here's another problems that are still related to the transportation problems. It is called the transshipment problems. In the transportation problems that we've seen before, shipments are only allowed from supply point directly to demand point. You can only send the items from the supply point to the demand point directly. However, in some cases, in reality, shipments are allowed to go through points before reaching the final demand points. So that is called the transshipment problem. We have 3 points in transshipment problems. We have a pure supply point, which can only send goods to another point, but cannot receive any goods. We have pure demand point, which can receive goods from other points, but cannot send goods. And we have transshipment points, which can both receive and send goods to the other points. So suppose all points in your problem can both receive and send goods to the other points. It means that all your points in your problems are transshipment points. So it's okay if you do not have pure supply points or pure demand points. Okay, keep that in mind. That supply points can only send goods. Demand point can only receive. If all your points can both receive and send, it means that all your points are transshipment points. Now let's see an example. So Week7.3 manufactures widgets at 2 factories, one in Memphis and one in Denver. The Memphis factory can produce up to 150 widgets per day. Denver factory can produce up to 200 widgets per day. Widgets are shipped by air to customers in Los Angeles and Boston. The customers in each city require 130 widgets per day. However, Week7.3 believes that instead of sending the widgets directly, there are also the other alternatives, which are sending the widgets through New York or Chicago first, and then from New York or Chicago, then to the final destination to either Los Angeles or Boston. The cost of flying a widget from one city to the other city is shown on this table. And then we are also given a graph here to show who can send and who can receive, who can do both. And from this graph, you can see that Memphis and Denver, they are pure supply points. They can only send out items. On the other hand, Los Angeles and Boston, they are pure demand points in this case because they only can receive goods. New York and Chicago, they both can receive and can send goods, so they are transshipment points. Okay, you may take time to pause the video and read this problem carefully. So as usual, the first thing to do is to balance the problem. Let's see if our problem is already balanced or not. So we have the total supply from all the cities that can supply something, in this case only Memphis and Denver. We get the total supplies of 350. The total demand of all cities, in this case we have LA and Boston, the total demand is 260. So it means that we have an excess of supply of 90 units, which means that we have to create a dummy demand point with the demand of 90 units. Now let's create a transportation table. So we know that the supplies from Memphis equals 150 and from Denver equals 200. We also know that the demand from LA is 130. The demand from Boston is also 130. And in the previous slide, we have seen that we need a dummy point with the demand of 90 units. Okay, so that's we have known so far. Now, what about the transshipment points like New York and Chicago? First, what we need to do is that we calculate S, which is the total available supply. In this case, we have 350 of total available supply. From Memphis, 150, and from Denver, 200. So S equals 350. For each transshipment point, it will have a supply equal to the point's original supply plus S. And the demand for the transshipment point equals to the point's original demand plus S. Okay, so we know that S equals 350. So let's start with New York. The supply for New York equals 0 because originally New York cannot supply anything, so it's 0, plus S. S equals 330, so now the total supply for New York is 350. Similarly for demand, the original demand for New York is 0. In the problem, we do not see that New York has any demand for itself, okay? So that's why here it is 0. 0 plus S, S equals 350. So the demand for New York is also 350. It's the same for Chicago because in the problem we do not see that Chicago has its own supply or has its own demand. So that's why it's 0 for supply and 0 for demand here. And do not forget to plus S. Again, S is the total available supply from all points that we have. Okay, here we only have supply from the pure supply points, but remember that S is available supply from all points. Once you have constructed the transportation table, you may just solve this problem using transportation simplex that we have learned before. So starting from finding a BFS with one of the 3 methods, and then perform step 3, calculating the U and the V, and then perform the step 4, which is checking all the C hat for all the non-basic variables. Okay, so just use the steps in the transportation simplex algorithm to solve this problem. And then suppose this is the optimal solution, then what we can interpret from this solution is that from Memphis, we send to New York 130 widgets, and from New York to Los Angeles. From Denver, however, we just send 130 items directly to Boston. Okay, so from Memphis to New York, 130, and then from New York to LA, 130, and then from Denver directly to Boston, 130. Whatever value that you see in the dummy or from a transshipment point to itself, then you can just ignore them because they don't really mean anything in the real world. They are just something that we need to make it easier to find the optimal solution using the transportation simplex algorithm. Okay, so that's the end of all the things that we're going to learn before the midterm exam, and then wish you all the very best for the midterm exam. As usual, if you have any hesitation or questions or anything, just feel free to contact me through email or anything. I promise I will answer your questions. Okay, so good luck for the exam and see you after the midterm exam. Thank you.